Okay. Hello, Kirtana. I think I'm audible. Okay.
Yes, sir.
So, yeah, yeah. So let's start with the next topic. Not, it's not a next topic. Basically, it's a part of solving the circuits. Okay. So the thing is division of current in a parallel resistance. Okay. So what does this mean? That assume I'm giving you some circuit like this. R1, R2. Okay. Okay. This is the complete circuit basically. So current I1 is going with this way, and this is like this is the thing. Okay. A and B. So total current is I1. So this part will become I1 and this is going to be I2. Okay, so there must be some potential difference, assuming it to be E. Okay, so potential difference across R1, okay, R2 and R1, you can call it as E. So we have to calculate I1 and I2, right? So how you can calculate this? You have two ways. I have not told you about the Kirchhoff's law, so let's leave that part. You know that E is nothing but I1 R1, right? And the same I can tell for this thing, right? Just confirm this part if you understand it.
Yes, sir.
All right, right? Okay. So before this, if you know that this I is the total current, right? It has been divided into two. It is bifurcated into two, that is I1 and I2. So I can simply say that I1 plus I2 is written in the form of I. Can you see this? If I just observe one thing, from here, what I'm going to get is I1 is equals to R1 times of, no, it is like E by R, and I2 is equals to E by R2. Yeah, so look, I have got the two values of I1 and I2, right? I can substitute it over there. And in another way, Kirtana, if I ask you, okay, let's not go with this way. Okay, I just misinterpreted the thing. Yeah, I wanted to calculate I1 and I2, right? And we have already studied how to calculate the total R equivalent. So what is R equivalent, Kirtana? That is going to be R1 times of R2 times of this and this. Is it? So Kirtana, can I say that the total E, this current, is nothing but total current supplied by the battery, this EMF, multiplied by the total R equivalent across the circuit. Can I say this, Kirtana? So it will come out as I is equals to R1 R2 divided by R1 plus R2. So I think till here you don't have any doubt.
Yes, sir.
Okay. So I can simply say that Kirtana I is nothing but equals to, what is it equals to? Okay, let's leave this part. And you also know that E is equals to I1 R1, E is equals to I2 R2. So you can see I just have to equate both of them. When I equate I1 R1 with this thing, I1, basically bigger I, this, what you have assumed, this get cancelled. What I am left with, current flowing through one resistor, like first resistor, is equals to total current multiplied by the other resistor divided by the sum of both. What is this? I2. Current, total current, other resistor divided by sum of both resistors. Is this clear, Kirtana?
Yes, sir.
Okay. What if I have more than these registers? Like if in case I have more than two registers, something like this condition. Assume I am having a three register. Okay. A simple way is like you can do the same thing in all conditions. You know that calculating R equivalent part is more important, right? So what is R equivalent out of this circuit? That is basically Kirtana, R equivalent is R1, R2, R3, right? And in the bottom side, what happens is basically whenever you are calculating R equivalent, now at the top you will be getting multiplication of all. In the bottom, you can start by any word, like start with R1, R2. How many total limits are there? Three are there. Na? So just leave one at a time. So right now I'm not taking three. After this, two, three plus two, three, one. Okay, this is the complete thing. Okay, you have to start from someone and to that particular point. Is that clear? This is a way you can do it in an easier way. Understood, Kirtana?
Yes, sir.
Okay. Now if I ask you, Kirtana, assume you are having a four resistance in the parallel. Okay, R1, R2, R3, and R4, right? So again, by using the same formula, basically it's an easier method. Okay, if you just get the pattern of this, now you don't even need to do one by R equivalent something. Okay, you can directly go with this way. So what the things you are having right now, you can say you have to start. Just take this thing, okay, and put the whole thing in the bottom. Just leave one thing one time. So you can say that right now you are leaving this thing. So you can write this. After this, leave this R1, R2, R3. After this, leave this thing R1, R3, R4. After this last one. R4. Understood, Krishna? What is happening at the bottom? I just need all the multiplication pairs except leaving the one. Okay, is that clear? You can get this verified in this way also. 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. Okay, so you can say that the LCM of this will nothing but R1, R2, R3 plus R4. What is coming to be here? I already have R1, so I'll be getting this thing R2, R3, R4, and so on for so on. Okay, this is what you are going to get. Is that clear, Kirtana?
Yes, sir.
Okay, so yeah, if you are clear with this thing, I'll just get you the current. Now, if I ask you, Kirtana, what is the current out of this? So you can simply say, sir, I1 is nothing but whatever the total current getting inside this R equivalent multiplied by, you are asking about 1. I will not write 1, I will write 2, 3, 4 and divided by this whole thing. Is that clear? Or you can say this I multiply by your R equivalent and remove this I R1, okay? Whatever you're looking for. So you can say that this 3 and so on, so on. Okay. Same for I2, I R1, R3, R4 and bottom is same. Okay. Understood, Kirtana, this way?
Yes, sir.
Okay. I don't think any doubt you might be having right now for this part.
No doubts.
Okay. Let me see if any problem I have. Just going more for the problem in the training. Okay, good. So I think I'll be giving you one problem, okay, and we will be doing the circuit analysis of this problem. Understood? So I'll just shift to the new page for this one. I think you can hear me. Okay. So analysis of electrical circuit. Okay, this is what we are going to do right now. So for this case, I can say, assume this is the circuit I'm making right now. 20 volt, 2 ohms, 8 ohms, 10 volt, 2 ohms. This thing is Kirtana 4 ohm, and the bottom is again 4 ohm. Okay. Um, are you there, Kirtana?
Yes, sir.
Okay. Okay. So basically, Kirtana, you can say that in this circuit I have some battery, some like two batteries is there, and some resistors are there, right? So when we do circuit analysis, what we used to do, you can say circuit analysis or includes calculations of variation, parameters of the circuit. Okay. So what we has to do in this case, current in each branch of circuit, potential difference across different point, you can say, or junction, okay, of circuit in purely resistive circuits. We can calculate equivalent resistance, okay, resistance, equivalent resistance of circuit, okay. Okay, so Kirtana, what do you think? The circuit which I have given to you, is it a purely resistive circuit?
No, sir.
No, right? Because it contains some of the batteries. So this says that, like, if you could remember, the circuits we have solved before, they were the purely resistive circuits. In those cases, we used to calculate equivalent resistance of the circuit, right? Apart from this, we have not done the other thing like potential difference across junction and branches. Okay. So what are junction basically? Junction is basically these are the points, right? These points where you can say two wires are meeting. Okay, two wires are joined, you can say, or you can say two different components are joined. Is that clear? What is the junction?
Yes, sir.
Junction is a point where one or more, like two or more than two components are joining or meeting, you can say. Okay. What is the branch? A single wire, you can say whole branch is that. Like this is one branch, another branch. This is whole branch. Okay. These are the branches. So for this, like we used to follow some of the standard rules. On the basis of that, we are going to solve these circuits. Okay. So circuit analysis is done using two rules, done with two standard laws. Okay, the first one is Kirchhoff's current law. Okay, and the second one is Kirchhoff's voltage law. Okay, so Kirtana, look, I'll just okay. This can be abbreviated as KCL. Okay, and this can be abbreviated as KVL. Okay, so Kirtana, the previous circuits which we have solved, in those circuits you can simply say that resistance, they were purely resistive, right? The circuits where you can easily figure out which is series, which is parallel, we don't much need of the Kirchhoff's laws, okay? But the circuits, which is a kind of combination, okay, where you can't directly say that it is a series, it is a parallel or something. In those cases, we really need some laws which can be applied and get the circuit solved. So here, in those cases, for example, if I gave you a circuit like this is a battery, okay, this is another one resistance, this is another resistance. Okay, let's do this first, okay? Then I'll move to the next one. Okay, so Kirtana, I'm giving you one problem. Just try to solve it. 1 ohm, 2 ohms, 3 ohms, and the 4. Make it 2. You make it 4. Make it 3 and 3. Okay, that's fine. Let's not make it 3. Okay, let it be 4 itself. And the voltage is given as maybe 20. So Kirtana, in this case, assume this is point A, this is point B, this is point C, D. Okay, so what you need to calculate is potential difference between AC, CB, okay, AD, and TB. These 4 points are given, and you have to calculate potential difference between all these 4 points. Can you solve this? Okay, do one thing: potential difference and current. Okay, can you solve this, Kirtana? This part?
Yes, sir.
Okay. So solve this. After this, I will tell you why it was like why you can solve this without using these two laws, and in which case you can't apply direct laws. Okay. So you can just solve this one. After that, I'll tell you. So try this one. Kirtana, should I, do I need to solve this one, or you can do it?
I'm doing it, sir.
Okay. So just try this one. And also, Kirtana, I just forget that time to counter you. You told me some equivalent resistance answer for this circuit, right? forget what kind of circuit that was. A and B. What was the answer you told that time?
Sir, in that all the three were in a series.
No, no, yeah, this was the case, right? So what was the answer you told Kirtana that time?
4 hours.
No, no, that is incorrect. Okay, I just didn't told you that time. Okay. Just solve this. I would after this. I will tell you the answer for that. Okay.
Sir, for AC, current is 20 ammeters. For
Uh,
CB, 10 ammeters. For AD, 6.6. And for DB, 5
wait. You
ammeters.
are getting 20 millimeter current.
Amperes. 20
Yeah,
amperes.
20 amperes current. Kirtana, I think. I don't, let's see. Okay. I still don't know what's the answer for this, but let's see. Uh, okay, yes, solved for the current. That is fine. Okay, wait. What is the current for this 1 ampere and 2 ampere?
20 and 10. Sir.
For this is 20 and 10. Okay, wait, Kirtana. Do you think this is correct? You can think in another ways. If I just tell you, Kirtana, assume some current is going in this branch. What do you think? Current across this and current across this. Will it be same or different?
Same, sir.
Same. So how this comes out as 20 or 10 and 10, 20. Okay, I'll just solve it. Okay. So Kirtana, look, in this circuit, if I ask you what I have asked you, potential difference, right? Okay, and current. So let's do one thing. Let's calculate the total current. Okay. So you know, Kirtana, I can get the equivalent resistance, right? What is that? This is 3 and 4, so I can say the 7, 1 and 3. So you know this is 3 into 7 divided by 10. Isn't it the total equivalent resistance of the whole circuit?
Yes.
Okay. So what is the current, total current, Kirtana? I'll remove this. And take this. Okay. So what is the total current? You can simply say the total current is nothing but total potential divided by this thing, right? Okay, so let's make this voltage to be 20. I just wanted it to be easier. So you can say that total current you are getting, that is 10. This is the total current. Total current means to say this is the current passing with this. Understood, Kirtana?
Yes, sir.
Till now? Okay. Now, Kirtana, if you see carefully, the moment it reaches here, it has two branches to go. This is one way, this is another way. So can I say, Kirtana, I will just bifurcate this. Okay, I don't know, Kirtana, what will be the individual part of the potential difference, but I know how to calculate current in these two different branches. We have just solved this. What is that? Just get the to equal resistance of this. What is that? 3 ohm, right? For this one, that is 7 ohm. Is it?
Yes, sir.
And Kirtana, we have just, I think, okay, in the previous page, I think, in the previous page, we have already solved. Wait, I'll just go back. Wait. Yeah, Kirtana, you can see that here we have already solved. If you have these two kind of circuits, we can easily calculate I1 and I2, right?
Yes, sir.
Okay, so what is going to be Kirtana I1 and I2?
And
What happened? Yeah. So from here, Kirtana, I can simply say that your I1 is nothing but total current, right? What I told you, whatever the total current multiplied by R equivalent. Okay. So assume this whole to be the R1, this is to be the R2. So can I say that Kirtana, this current is nothing but R2 divided by R1 plus R2? Or just write the equivalent resistance, this thing, and remove the part you are looking for. You are looking for R1, just remove it. and I2 will be equals to 10 into R1 divided by R1 plus R2. Is that clear, Kirtana, or I have doubts? If you have doubt, just clarify it in the way itself, okay?
No doubt, sir.
No doubts, it's clear, right? So what is the answer you are going to get? The R2 is 7, right? So this is 10 into 7, and summation is 10. It's summation is 7 itself, right? R1 plus R2. No, it is 10. 3 plus 7, 10.
10.
Clear? So what is the I1? You can say here 7 current. So Kirtana, do I really need to solve the I2? Or I
No,
can
no.
get no,
10
I
minus.
don't get, right? I can simply say that this is 20, this is 7. I know the total is 10. 7 is going this way, so I know that 3 ampere is going in this way. So I can simply remove all of these unnecessary. Yeah. So Kirtana, you can say that how much is this current? 3 ampere, and this is the 7 ampere, right? Even you can verify it now. You know the potential difference across these two terminals is 21, right? Is
Yes,
it?
sir.
Okay. So you can say 3 plus 4. What is the resistance, total resistance in this branch? 7, right?
Sir.
And what is the current flowing through this? You can say I into R. So 3 into 7, 21. Isn't it the potential difference across these two terminals? Right. That's the correct. And here also, this is 3 and 7. What we are going to get? The same, 21. Understood, Pritana?
Yes, sir.
Okay. That is one way to do this. All right. Now, Kirtana, I asked you to calculate current. So we have already calculated the current. What is the left part? The another part is to calculate potential difference, right? He is going this I1. Here is I2. So, Kirtana, I told you calculate potential difference at these two terms, right? So, if I ask Kirtana, I'll just take this branch for now and I will take it here itself at this part. So, can I say that Kirtana, the branch is something like this? One resistance here, another resistance here. What is this resistance? This and 4. Kirtana, if I say this is point A, this is point B, you know what is the potential difference AB? How much is that, Kirtana?
Same.
No, no. What is the potential difference across this A and B?
21.
21, right? So, yeah, this is 21. And what is that? That is nothing but you can say it is divided into two parts. Can I say this is V1 and this is V2? Because this 21 is total resistance, right? So some potential is dropped across this point, some potential is dropped across this point. Can I say this, Kirtana?
Yes, sir.
Okay. What is V1, Kirtana? I know current flowing through this resistance is how much? 3 ampere, if you could remember. In this branch, I had current as 3 ampere only. Look, 3 ampere, 7 ampere was here, and 3 ampere was here, if you could remember. So can I say, Kirtana, the potential, this V1 is nothing but 3 into 3, 9, plus this is going to be 3 into 4, 12. If you see, the sum is still 21. So understood how we have to calculate potential difference across this. You can see I have got the answer is correct. Okay. So what I was looking for, OAD. What is AD? That is 9. What is DB? That is 12. Okay. Is this clear, Kirtana?
Yes, sir.
Okay. Okay, I will give you another way also. Let's do this. So one way, Kirtana, you got to know, right? How to calculate potential across these terminals.
Yes.
I will use this circuit, this branch by using another way. Okay. So let's take this branch. This is 1 ohm, this is 2 ohm, and this is current is I, basically 7 ampere. Okay. So how to calculate potential across this? Assume this is the center terminal, right? Can I say this statement will be center terminal?
Yes, sir.
Okay. So if I say this is V1, if I say this is V2, so you can simply say that V1 is equals to no, V1 plus V2 is equals to how much total and what is whatever the potential you have E that is. But I just have to calculate this part. So can I say that this V2 I can rewrite as E minus this is not a good way to do it. Okay, you already know I1 and I2, right? So you can simply say, okay, wait, yeah, you already know the current, right? So you can simply put I1 and I2. I forget. Whatever I was going with the way, that is the way when you don't know the current value. Okay. If you know the current value, what is the resistance over here? That is I. This is 1, right? So you can simply say 7 into 1 will give you how much? 7 volt. Here you have 2. 7 to the 40. This will give you 40 volt. If you see still the sum is 21. Is that clear, Kirtana?
Yes.
Alright. Any doubt, Kirtana?
No, sir.
Okay. If you see Kirtana, look in case of series, if I if I talk about the series, the one with higher resistance have higher potential drop. The one with lower potential, lower resistance, has a lower potential drop. Can you see this?
Yes, sir.
Okay. But in case of parallel, if you look, okay, this is about the potential. Let's talk about the current. When you keep two resistance in a parallel combination, the one with higher resistance has a lower current, and the one with lower current, wait, higher resistance, lower resistance, higher current. Is that clear, Krishna? Why this is? Because when you have two things in the parallel, okay, the potential across them is supposed to be same, right?
Yes, sir.
Basically, I1 R1 is equal to I2 R2. This is supposed to be same. So if my R1 is greater than R2, but I need to both to be balanced, right? If this is greater, this is lesser. So in that case, I have to increase this one and I have to decrease this one such that it can be clarified. Okay. Is that clear, Kirtana?
Yes,
Basically,
sir.
this is a balancing. Okay. So any doubt, Kirtana, in today's session?
No, sir.
Okay. Okay, Kirtana, if you see in this circuit, I was able to solve it because I was clearly seeing that this is the series, this is series. These two series are in the parallel with each other. But what if Kirtana I join these two? Now I have joined this line. Okay. Let's remove this. Okay. Now Kirtana, this is the circuit. Okay. Assume this is not a wire. Yeah. If I just make it like this, Kirtana, what do you think? Will you be able to solve this one?
Yes, sir.
How?
Since it's a conducting wire, we can ignore it.
Wait. Ignore it mean to say it will be like this, is it?
Yes, sir.
But if you do this, these two came in the series, these two came in the series, but no, it is not the case. Why it is not the case? Because when this wire was there, assume look, if you ignore this, what is going to happen is whatever the current coming in this way, it is just going in this way. But if this wire is connected, there is a one more path, right, Kirtana? So can I say that Kirtana, this is a wire, so there is no potential drop. Can I make it just a point like this? So can I also say that Kirtan, this is basically nothing but these kind of circuit. One, this. Can I say that Kirtan, this is the circuit we had that case. What is the difference? You can see this is just, these are just a wires, right? I can do one more good part is I can simply remove this and I will be making like this. This is your current, this is your resistance. In the previous case, I just added a wire and extended these two, right? Because you can see these are just a combination of wire. You can make it as a point also. Can you see this case? Still these two are in the parallel, these two are in the parallel. Solve these individually. You will get two equivalent in the series. Can I say that?
Yes, sir.
Okay, you solve this. But what about this one? Here you have a resistor. You can't even ignore this. This is not even a wire in which you can say that okay, this is something. So in these kind of Kirtana problem Kirtana, we have two ways to solve. Either KCL, KVL, this is one way. This is ideal way. Another is Wheatstone bridge. But there's a certain condition for Wheatstone bridge. If it satisfies the condition, this will get ignored. But if it does not ignore it, you have to apply this because in this condition you can't say like you can't say this is in series and parallel. How you can say this is individual resistance, this is individual. If you say this is in the series, no, there's a interference of other resistance. If you say these two are in the parallel, no. If they are, they will only be parallel if they are directly connected. There's a resistance in between. Understood, Kirtana? You can't say these are parallel series. So in these kind of cases, we need KCL and KVL. Understood?
Yes, sir.
Okay. And about that case, the problem one, two, again one. The answer for this one will be Kirtana, what I'll say, 2 divided by 2 plus 2, 2 plus 2 plus 1. So it will be basically 2 by 5. This is the answer for this one, okay? The reason is Kirtana, this circuit is, if you see carefully Kirtana, I said these are the two wires, right? This is A, this is B. If you see Kirtana, this is just a wire, is it? No, I have made the circuit incorrect this time. It was not the circuit actually. Circuit is quite different, which I gave you. This was the circuit that time. Three wires in the same way. This was connected with this was connected with this. Kirtana, could you remember this is the circuit?
Yes, sir.
Kirtana. Okay. If you see Kirtana, this point and this point are just connected with a wire without a component. Can I say Kirtana, these 2 points are the same?
Yes, sir.
So can I say that I will just take my B? Okay, what you have to do is just mark this as C, mark this as B. Can I say Kirtana, my C and B are the same?
Yes, sir.
My D and A is also the same because you can say they are just a wire.
Yes, sir.
Okay, let's start making it. You know there is a resistance between A and C is nothing but B. So can I say that if I have a point A, I have a point B because my C is equals to B. I have, okay, wait. I have a resistance between A and C. Basically, B is equals to C. So I can simply say this R1 is across this. Okay, what about C and D? You know, Kirtana, I have this R2 in between C and D. What is C? This terminal is C because B is equals to C. What is B? A. Can I say Krishna, this is R2? And the third one, D, B. Basically, this is B. B is equals to C. This equals to A. Again, this resistance also lies in between these two terminals. So what you realize, Krishna, this whole circuit comes up into parallel combination and you have these R1, R2 and R3. And what was the values? 1, 2, 1. If you solve this, you are going to get the answer as 2 by 5. Okay?
Yes, sir.
Any doubt, Krishna?
No, sir.
Look, in case of when you are solving series or parallel combination, it is not important how it looks like. It is important in which between two terminals it is connected. Okay, you can see if you look in a perspective of series, it will look like series combination, but it is not. Okay, you always have to figure out which two terminals it is connected between. You can see these. Okay, these are the two resistors, right? There's a terminal in between. Okay. So you just have to look where this terminal is going. Is it just an open wire? If it's just an open wire, you can say, okay, they both are in the series. But no, this is connected with this resistance. Okay. So this is why this is not in the series. You have to make a proper way. Mark all the points, C, B, and something. Put these distance and make an equivalent circuit out of it. Any doubt, Kirtana?
No, sir.
Okay, this is all for the day, Kirtana. I end the session like this. We'll get this PPT. In the next class, we'll do something else. I'll end the session by this. Good.